Okay, now let's discuss this second exam. Problem 1. We're going to solve each equations. So we have several equations. First, log 2 of x minus 1 plus log 2 of x plus 4 is equal to 4. And by the logarithmic function property, you put x minus 1 and x plus 4 as a product. It is equal to 4, and then it is equivalent to x minus 1 times x plus 4 is equal to 2 to 4th power. 2 to 4th power is 16. 2 to 4th power is 16. And then you multiply them out. Right? So x minus 1 times x plus 4 is x squared plus 3x minus 4, and move 16 to the left side is x squared plus 3x minus 20 is equal to 0. And then you will get x plus, we are going to apply the root formula. X is denominator is 2, negative 3 plus or minus square root of b squared minus 4a and c. Alright, so it's negative 3 plus or minus square root of, this is 89 over 2. 89 over 2. And so we have two solutions. X is negative 3 plus square root of 89 over 2, or x is negative 3 minus square root of 89 over 2. But this number should not be included because we require x minus 1 to be positive, but this one does not satisfy. So x cannot be negative 3 minus square root of 89 over 2. Hence, there's only one solution. This one is the solution. So the solution is x equal to negative 3 plus square root of 89 over 2. All right, so this is the first one. Let me check if it's all correct. Yeah, I think so. Yes. The other one is 3 to the power of 2 minus 2x is equal to 5 to x. Is equal to 5 to x. So you can take whatever logarithmic function you want. For example, if we take logarithmic function with base 3, so the left side becomes 2 minus 2x. Right side becomes a log 3 of 2x, 5 to x, which is x log 3, 5. And then you move this 2x to the right side. So 2 is equal to 2x plus x log 3, 5. So you factor out x, you get x 2 plus log 3, 5 is equal to 2. I interchange two sides. So x is equal to 2 over 2 plus log 3 of 5. So this is the answer. This is the answer if we apply logarithmic function with base 3. Right? Okay, so this is the first problem. Second problem, it is similar to the practice. A child is spinning a rock at the end of a 2-foot rope at the rate of 180 degrees per second. So the angle speed is equal to 180 degrees per second. If we only use the angle speed, that's fine. We can use 180 degrees. But if we want to combine this with the linear speed, so we have to use radian instead of degree. So this is a pi radian per second. Pi radian per second, radian, RAD. And in this case, the linear speed is the angle speed times r. The linear speed is angle speed times r. So it is pi times 2. The rope is 2 feet. So it's 2 pi. Then this is a feet per second. Feet per second. So, no. Yeah, it's a 2 pi. Feet per second. That's the answer. So you must change this degree to the radian because you're going to do multiplication, direct multiplication with the numbers. If you only use the angle in the trigonometric functions, then it doesn't matter what unit you use. But if you want to combine it with the radius, you have to use radian. All right. Problem 3. Problem 3, we are talking about, remember, the arc length. This is angle, this is r, this is arc length. Arc length is, by definition, r theta, by the definition of a radian. And here, this theta must be radian, must be in the radian system. So, r is 2 inches. Theta is 60 degrees. 60 degrees is pi over 3 radian. 60 degrees is pi over 3 radian. So this arc length is 2 pi over 3 inches. So the units follow the radius unit. So the answer S is 2 pi over 3 inches. And similarly, if we have this piece of shape, this sector, then this region has an area when you have radius r and a central angle theta. Theta, not pi. Theta r square. So it's a 1/2 theta angle, central angle times r square. So 1/2 is 1/2. Theta is 1/2 pi radian. So you already just get radian, so you don't have to change anything. And the radius is 3 meters. 3 squared is 9. So it becomes 9 pi over 4. Check here. R has a unit meters. This is meters. 9 meters. So now it becomes meter square. So it's m squared. So the sector has area m squared. 9 pi over 4 m squared. All right. Problem 4. We have a acute angle. Acute angle means it's between 0 and pi over 2. For such angle, all 6 trigonometric functions are positive. And we know sine theta is 1 over 5. Sine theta is 1 over 5. We're going to find the cosecant theta. Cosecant theta. Remember, what is a cosecant theta? Cosecant theta is 1 over sine. Cosecant theta is 1 over sine. So sine is 1 over 5. 1 over 1 over 5 is a 5. So nothing you need to do. Just directly apply the relation. All right? This is the simplest problem. Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent. Remember, those are the relations from the definition. Right? And also we have that trig identity. Sine square plus cosine square is equal to 1. That is the fundamental one. It follows from the Pythagorean theorem. Okay, next, problem 5. Problem 5. What is the problem 5? Well, finding the exact values of each expressions. Finding the exact values of each expressions. So 1 minus tangent pi over 6 squared and plus cosine pi over 3 squared. All right, so tangent pi over 6 is square root of 3 over 3. Cosine pi over 3 is 1/2. So you just memorize them. So it's 1 minus square root of 3 over 3 squared and plus 1/2 squared. Square root of 3 over 3 squared is 1 over 3. This is a plus 1 over 4. Minus 1 over 3 plus 1 over 4 is, what is this? 11 over 12. 11 over 12. These two is negative 1 over 12. All right, so the answer is 11 over 12. The other one, 1 plus what? Secant 30 degrees squared minus tangent 45 degree squared. All right, secant, remember secant, as we know, secant is 1 over cosine. Cosine 30 degrees is square root of 3 over 2. So secant 30 degrees is 2 over square root of 3. And then you square it. Tangent 45 degree is 1. Tangent 45 degree is 1. So this is 1 plus, this is 4 over 3 minus 1. It's a 4 over 3. 4 over 3. That's it. That's it. Okay. Okay, problem 6. Problem 6. Find the exact value of each of the remaining 5 trigonometric functions of theta with cosine theta equal to negative 4 over 5. Theta in quadrant 3. Theta is in quadrant 3. In the third quadrant, remember tangent, cotangent, positive, others negative. Sine, cosine, cosecant, secant, they're all negative. All right, in the quadrant 3. Now let's check. From here, we know what? We're going to use the triangle. This is angle theta. The adjacent is 4. The hypotenuse is 5. So the cosine is 4 over 5. I originally ignored this negative sign. We're going to use more or less the reference angle. Okay? And then you'll use the Pythagorean theorem to compute the opposite side. It's a 5 squared minus 5 squared minus 4 squared, which is a 3. It's a 25 minus 16 is 9, square root of 9 and 3. So this side is a 3. All right, so then the sine theta is going to the opposite over hypotenuse, 3 over 5. But we know sine is negative, so it's a negative 3 over 5. Cosine theta is negative 4 over 5. Then tangent theta. Tangent theta is opposite over adjacent, so 3 over 4. It's positive, so there's no negative sign. Once you determine those sine, cosine, and tangent, you're going to flip them. So cotangent theta, you flip them, you get 4 over 3. And secant theta, you flip it, is negative 5 over 4. Sine theta, you flip it, the cosecant theta is negative 5 over 3. And that's it. Right? That's problem 6. Problem 7. Problem 7, we have y equal to negative 3/2 cosine of 1/2 x minus 2/3, 2/3. Then the amplitude is absolute value of negative 3/2, which is 3/2. The period is 2 pi over the coefficient of x, 2 pi over 1/2 is going to be 2 pi times 2, which is 4 pi, and that's it. All right. Problem 8, we find the exact values of each expression. Tangent to negative 7 pi. Tangent has a period pi, so you negative 7 pi, you remove all the multiples of a basic fundamental period, so it's equal to the tangent 0. Tangent 0 is 0. And secant negative 3 pi over 4. Secant, remember, secant is a reciprocal of cosine. Cosine is an even function, so you can ignore this negative sign. All right, and cosine 3 pi over 4 is what? Is a square root of 2 over 2, but 3 pi, so it's in the second quadrant, it's negative. All right, so 3 pi over 4, it's a reference angle. This is a 3 pi over 4. It's a reference angle, it's a pi over 4. So you're going to recall what is a cosine pi over 4. Cosine pi over 4 is square root of 2 over 2. But it's in the second quadrant, it's going to be negative square root of 2 over 2. Right? This is a reference angle. This is the value of a cosine with respect to the original angle. And then flip it, it's a negative square root of 2. By the way, 2 over square root of 2 is equal to square root of 2. So you flip it, you will get negative 2 over square root of 2. That is negative sign, copy. 2 over square root of 2 is square root of 2. And then cosine of negative 30 degrees. Again, cosine is an even function. When you have a negative sign, you just remove them. Just get cosine 30 degrees. Cosine 30 degrees, square root of 3 over 2. Square root of 3 over 2. And sine negative 225. What is 225? 225 is 180 plus 45. 225. All right. So you see, it's in the this is a pi 180. This one is 225. So the reference angle is 45 degrees, but it's in the third quadrant. And negative sign, you can move it forward. All right. So first you have this negative sign, and then the sine 225, the reference angle is 45. Sine 45 is equal to square root of 2 over 2. And it's in the third quadrant, so it's a negative square root of 2 over 2. In the third quadrant, sine 225 is equal to negative sine 45. So that's why you have negative sign. This negative sign is inside the parenthesis. This negative sign comes from the external, comes from this negative sign. So negative canceled is square root of 2 over 2. This one is a little bit complex. All right. Okay, so problem 9, we're going to graph sine 3 times sine 4 pi. 4x, not 4 pi, my bad. We're going to graph this function with at least one period. The hint is to use the key points. So, okay, what do we know? We know 4x. We are going to let 4x be 0, pi over 2, pi, 3 pi over 2, and 2 pi. 4x will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. In the corresponding position, x is going to be x is 0, 4x is pi over 2, then x is a pi over 8, 4x is a pi, then x is a pi over 4, this is a 3 pi over 8, and this is going to be pi, what is this? Pi over 2, right? 4x is equal to 2 pi, x is a pi over 2. Okay, so now let's check. Here, I'm going to get a bigger one, pi over 2, pi over 4, pi over 8, and 3 pi over 8. When x are those values, 4x are those values. So 4x is 0, sine 0 is 0, times 3 is still 0. When 4x is pi over 2, sine pi over 2 is a 1, times 3 is 3. So y is going to be 3. Let's assume this is a 3. And then 4x is a pi, sine pi is 0, times 3 is still 0. 4x is 3 pi over 2, sine 3 pi over 2 is negative 1. So times the 3, it becomes negative 3, so it's possibly here. And 4x is no, here, this one. This is 0 already, this one. When 4x is 2 pi, sine 2 pi is 0, it's here. So if you sketch it smoothly, looks like this, but those values are for x. This is a 1 period. Okay. All right, so that's the discussion of this second exam. The second exam just gave us the basic idea about the trigonometric functions, together with a little practice of logarithmic function and exponential functions. I hope you're okay with the explanation. If you have questions, we can discuss that. Okay, thank you.